Introduction to Computers, Chapter 1. People have always found it necessary to perform calculations, and it's often convenient to have devices that help do this calculating. One of the earliest of these devices was the abacus. The abacus was first designed over 2,000 years ago and is still in wide use. In Europe during the 17th century, they developed a number of very powerful calculating devices. Some very famous men got involved in this: Pascal, Leibniz, and Isaac Newton. The 19th century, Charles Babbage designed a programmable computer. Now, he was never able to actually build one of his analytical engines, and functioning programmable computers weren't actually developed until the 20th century, the 1940s. The first functioning programmable computers were the Colossus in England. They used to break the German codes in the Second World War. And in the United States, they developed ENIAC to calculate the ranges for artillery shells, and later on they used it for the hydrogen bomb. The first commercial computers appeared in the 1950s. There was the Lion LEO-1 in England, and UNIVAC, Sperry ran UNIVAC, which was the first widely sold commercial computer, and IBM shortly thereafter produced the 650. In the 1960s, transistors and later integrated circuits started replacing vacuum tubes in electronic computers, resulting in units that were much smaller, cheaper, and much faster. Moore, in 1965, predicted that integrated circuits would become more and more complex, smaller, more powerful, that essentially the power of computers was going to be doubling every 1 to 2 years. This is what's called Moore's Law. Since integrated circuits were much cheaper than vacuum tubes, they made personal computers and home computers possible, and even portable and handheld computers. Graphical user interfaces were developed to make computers easier to use by people who were not computer specialists. With cheaper, smaller, and more easily used computers, there was a great proliferation. Lots and lots of people were buying these computers, and with lots of people buying and using computers, lots of people were developing applications to run on the computers to sell to these people. Artificial intelligence, AI, officially the study of intelligent agents. An intelligent agent is a device that can sense its environment and determine actions that will let it achieve goals that are built into it. More colloquially, artificial intelligence is applied to any kind of a machine that acts like it is doing things that people associate with human minds, learning, problem solving. We generally classify artificial intelligence to include understanding human speech, playing strategic games like chess and Go, controlling cars, routing contents in content delivery networks, doing military game simulations. Traditional goals for AI research include reasoning, representation of knowledge, planning, learning, natural language processing, perception of and manipulation of objects. The long-term goals are come under the heading of general intelligence. There are people who think that artificial intelligence could be a danger to humanity if it keeps growing and growing. Other people think that artificial intelligence has the potential for creating mass unemployment. As I said earlier, the term artificial intelligence refers to computing machines that mimic cognitive functions associated with human minds, human intelligence. In 1950, Alan Turing addressed the problem of describing and measuring artificial intelligence. He proposed an experiment that later came to be called the Turing test. He called it the imitation game. The test involves an attempt to define a standard for determining whether a machine could be called intelligent. The idea that he proposed was that a computer could be intelligent, could think, if a human could talk to it, use natural language, conversing with it, asking it questions, listening to its responses, to determine whether he was talking to a computer or a human being. The test that he proposed had been modified as being used the basis for a widely used test, the CAPTCHA test, used widely throughout the internet to determine whether a user is a human being or a computer program. Now, artificial intelligence systems have become much more complex, much more sophisticated. Recently, things called chat boxes have been developed. The most famous, widely used, widely described one is the Chat GPT by OpenAI. A chat box, or an AI chat box, artificial intelligence chat box, or a virtual agent, is a computer program that uses artificial intelligence and natural language processing to interpret users' statements and questions and generate responses, often referencing databases going through the internet. Chat boxes are using very complex algorithms and are providing extremely detailed responses. Been used to produce essays that respond to course assignments and to essay exams. There's some debate concerning the quality of the results. The best ones seem have been assigned a grade of C by the professors designing the exams or setting up the assignments. But they are clearly creating results that pretty much satisfy the Turing test. Another recent development have been artificial intelligence that create works of art, typically digital works of art. Artificial intelligence image generators. Companies that have created those, the more famous ones are Adobe, OpenAI, also known for ChatGPT, and Shutterstock. The programs are controversial. A number of artists have filed a lawsuit alleging that the companies are infringing on the artist's copyrights. They have made use of copyrighted images to train the artificial intelligence art generation tools. And of course, these artists have never given their agreement or been paid for the works that have been used to train the machines. Modern computing systems are being used more and more to implement virtual reality systems. The term virtual reality, or VR, refers to an experience taking place in a simulated environment. These simulated environments, can be similar to the real world that we live in, but could also simulate situations completely different. Applications of virtual reality include entertainment, gaming, but it also enjoys wide use for educational purposes, medical training, military training. Currently, most of the virtual reality systems use virtual reality headsets or multi-projected environments to generate realistic images, sounds, other sensations that simulate the user's physical presence in a virtual environment. A person using virtual reality equipment can look around in the artificial simulated world, move around in it, interact with the virtual features. It's commonly created using VR headsets consisting of a head mounted display with a small screen in front of the eyes. Virtual reality effects can also be created with specifically designed rooms having multiple large screens. Virtual reality typically incorporates auditory and video feedback, but also allows other kinds of sensory and force feedback using haptic technology. Haptic technology, kinesthetic communication, 3D touch, refers to technology that can create the experience of touch, applying forces, vibrations, or motions to the user. The mechanical stimulation can be used to give a physical sense of a virtual object in a computer simulation, allows us to control virtual objects in a virtual world, and enhance the remote control of machines and devices for telerobotics. Haptic devices could also incorporate tactile sensors that measure forces exerted by the user on the interface, most commonly game controllers, joysticks, and steering wheels. Voice user interface makes spoken human interaction with computers possible. It uses a speech recognition system to understand spoken commands and spoken questions, and will use a text to speech system to play a reply. The main function of a VUI is to support interaction with the computer that doesn't require use of hands or eyes, allows the user to focus their attention away from the computer, from the system. Examples of VUIs are virtual assistants, Siri, Google Assistant, Cortana, Alexa. Now, in around the 1960s, and the computer manufacturers started specializing, producing different kinds of computers for different groups of users. During the 60s, they developed mainframe computers, mini computers, supercomputers, personal computers, and later PDAs, smartphones, tablet computers, and embedded computers. The term mainframe originally referred to the large cabinets that housed computing units. But later, when various kinds of computers started to become available, the term mainframe came to be used to distinguish the bigger high-end machines from the less powerful, less expensive units. IBM has traditionally dominated the mainframe market. Their dominance started with the 707,000 series and continued with the 360 series. When smaller computers, less powerful computers came on the market, people referred to them as mini computers and the bigger ones as mainframe computers. But later, as the personal computers came on the market, they were much smaller than the computers that had been referred to as mini computers, and the term mini computer came to refer to something bigger than the personal computer, the microcomputer, but smaller than a mainframe. The PDP-8 by Digital Equipment Corporation was one of the earliest computers referred to as a mini computer. The term mini computer tends to be misinterpreted as anything very small computer, and so the term mid-range computer is preferred. The first computer that was referred to as a supercomputer was the CDC 6600. That came out in 1964. It was designed by Seymour Cray, who for several years, decades, was the preeminent supercomputer designer. Created his own company to produce supercomputers. In 1976, his company's Cray 1 was the most successful supercomputer in history, sold much faster than any of the others, and sold more than any up to that time. In 2015, China took the title with their Tianhe 2 computer. And in 2018, the US took the title back with the Summit computer produced by IBM, installed at Oak Ridge National Laboratory. The US also contracted another IBM computer designed to be 50 times faster, computer to be named Frontier. Frontier was scheduled for completion in 2021, designed to be exascale, capable of 10 to the 18 flops. But they didn't make the 2021 scheduled date. The completion date is now scheduled for sometime in 2023. Meanwhile, Japan, the Fugaku, produced by Fujitsu at the Riken Center for Computer Science in Kobe, was recognized as being the fastest supercomputer in the world. As of 2019, China had the most supercomputers with 227. The US only had 109. Supercomputers get used in a lot of computational intensive tasks in lots of fields: quantum mechanics, weather forecasting, climate research, gas and oil exploration, molecular modeling, computing the structures and properties of chemical compounds, biological macromolecules, polymers, and crystals, physical simulation of moments of the Big Bang, aerodynamics, nuclear weapon detonation, nuclear fusion. And throughout their history, supercomputers have been essential in cryptanalysis. Personal computers are computers, general purpose computers, that are small enough and cheap enough that people can buy them, individuals can buy them and use them, and they're intended to be used by the purchasers, no, not to require professional computer operators. The earliest personal computers were sold as kits, mostly to hobbyists and computer technicians who are interested in working on them from their homes. The first mass-marketed personal computer was the Commodore PET, which came out in January of 1977. In the same year, about 6 months later, Apple II came on the market, and at just about the same time, the TRS-80 from Tandy Radio Shack. It wasn't until about 4 years later, 1981, that IBM started producing personal computers, but it didn't take long before the IBM took over the market. It wasn't long before the personal computer market split into two distinct kinds of computers: desktop and laptop. The desktop computers sit on or under or beside a desk, and desktop computers require an external power source, a wall plug they can plug the computer into to get its power. Laptop computers have come to have essentially the same capabilities as desktop computers. They are, of course, a little more expensive and more difficult to upgrade. As the technology got better It was possible to make your computer smaller, small enough to hold in one hand, and the portable computer merged with the pocket calculator to become what they called a personal digital assistant, or PDA. PDA was a mobile device that functioned as a personal information manager. They were discontinued in the early 2010s after the smartphones and tablets took over their place in the market. The first PDA appeared in January 1992. It was referring to the Apple Newton. A couple of years later, in 1994, IBM introduced the Simon, the first PDA with mobile phone functionality. It can be considered to be the world's first smartphone. A couple of years after that, Nokia introduced the Communicator 9000, a PDA with full mobile phone functionality. The Communicator became the world's best-selling PDA and spawned a whole new category known as PDA phone. We now call those smartphones. Palm was another entry in this market beginning in 1996. Smartphone combines the features of cell phone and other mobile devices. PDA, media player, GPS device, also built-in computer. Most smartphones have a touchscreen, and their built-in computer can run third-party apps and will typically contain cameras built in. A tablet computer is a device in between smartphone and laptop, bigger than a smartphone, smaller than a laptop. The first tablet was the iPad, released in 2010. Tablets typically come equipped with cameras, microphones, and accelerometers. They have a touch screen where you can use your finger or a stylus to substitute the mouse in standard laptop computers, and has a virtual keyboard where you can use your finger or a stylus to type. As the computer components have gotten smaller, cheaper, requiring less and less power, it's become possible to design specialized computers and embed them in devices. They are being embedded in lots and lots of different kinds of things: digital watches, MP3 players, traffic lights, hybrid vehicles, and TV sets. When you build a computing capability into home TV sets, you get what is called a smart TV. This gives the advantage of the TV's large viewing screen much larger than you'll find on a typical desktop computer, much larger than you'll have on a laptop or a smartphone. Of course, the smart TV is in no way portable, so you don't have that. Of course, having computer capabilities, it has the option of connecting to the internet and installing apps. Users can watch movies and shows when they want to. They can stream them instead of when the network happens to broadcast them. Smart TVs also give many new entertainment options, streaming videos, games, social media, controlling internet connected gadgets throughout a house. Smart TVs use apps to connect to websites like YouTube, Netflix, Hulu, and let you connect to social media sites, Facebook and Twitter. Users can pair their keyboards, smartphones, or tablets to their smart TVs to give to allow them to interactive to do input, making them as user friendly as their PCs. As computers become more and more common, were used for more and more different things, it started to become important to move data from one computer to another. And of course, with more data movement, it became more important to do it quickly and efficiently. This was the main reason for developing computer networks. A computer network is a collection of computers and computing devices that are connected by communication channels. The individual entities, the computers, the printers, and so on, are connected to a network. They're called nodes on the network. Networks come in various sizes. The smallest are called local area networks or LANs. A local area network connects a few computers and support movement of information from one computer to another. They are also designed to share access to resources like printers and modems. At the other extreme, the largest network is the internet that connects millions of users. There are two general classes or types of computer networks. There are client server networks and peer to peer networks. A client server network has two types of nodes, clients and servers. A client node is a computer that's used by a user to connect to a network and make requests of servers. The server is a computer that receives and responds to these requests. So a server is a node on the network that provides services to clients. Usually, the service is in the form of some kind of information, receiving or processing information from clients. Another kind of network is called a peer to peer network. In these networks, each node can function as a client and also as a server. The client server model, a node is a client or a server, not both. Peer to peer, each node can function as either and or both. So each node then has more or less equivalent capabilities, responsibilities, status. These are often abbreviated using the acronym P2P. Many embedded systems connect and exchange data. This then provides direct integration of physical devices into our more traditionally computer-based communication systems. Results in improved efficiency, economic benefits, and reduced human exertions. Then we have physical devices, vehicles, home appliances, other items with embedded electronics, software sensors, actuators, all connected, interchanging information in a network, normally using the internet to provide interconnection. This network of devices is called the Internet of Things. The Internet of Things has expanded internet connectivity beyond our traditional computational and communication devices, desktop, laptops, and smartphones and tablets, expanded to include a broad range of traditionally non-internet enabled devices, everyday objects. With embedded technologies, these devices can communicate directly, can interact using the internet to provide an interconnection, and they can be remotely monitored and controlled. The Internet of Things also includes driverless vehicles, a branch of internet application that has started to gain a lot of attention. We've greatly improved communication speed that supports visual communication as well as audio communication. Video telephony or video conferencing allows individuals in widely separated locations to have meetings, face to face meetings on short notice. This saves time and money for businesses. VoIP technology can be used to support desktop video conferencing, which allows low-cost, convenient face-to-face meetings without requiring participants to leave homes, desks, offices. This is especially convenient for businesses or schools which have offices in widely separated locations or schools with multiple campuses. This VoIP video conferencing technology can also be used to support telecommuting, allowing employees to work from home. In 2010, there was a research report that checked with a number of 1,800 different corporate employees and found that well over half of them who had access to video conferencing used it a lot. It turns out to be a very popular topic. Probably the first major provider of video telephony services was Skype, but Zoom has recently become a very dominant player in that market. With computers and computer technology becoming more and more widely used, businesses started connecting their computers and equipment in private local area networks. The private computer networks provide numerous benefits. Of course, if they didn't, nobody would use them. But if you're connecting nodes over an area larger than just a single building, it gets awfully expensive very, very fast. And if you have traveling salesmen, roaming representatives, it is going to be impossible to construct a private network connecting all of those kinds of users. And that was why virtual private networks, VPNs, were developed so that businesses and schools of this type could have the benefits of private networking without having to actually construct their network, the physical infrastructure for the networks. The virtual private networks use public networks for their communications, but they function as if they were working on a private local network. They use software to use the public networks to emulate private networks.